when dealing with properties of exponents, as a review, exponents indicate powers. So looking at these, we know that we have here anything to the 0 power is going to be equal to 1. So a to the 0 power is equal to 1. Of course, a can't equal 0 because anything times 0 would be 0. So we eliminate that from an option. And then if we have here, we have a to the m over a to the n equals a minus n. And if we look at that as an example, let's take x to the third over x to the second equals x to the third minus second, which is x to the first. Expand that out some more in case that seems a little bit unusual. X to the third is x cubed, x times x over x squared, x times x. So when we are able here now to cancel out those as a value of 1, therefore, again, these two things are equivalent. So when dealing with fractions. Let's see here. So here's the reciprocal. A to the negative n is the same thing as n to 1 over a to the n. Here we need to make sure, this one right here, we need to make sure that a times b, ab is raised to the power of n, so we know that that n applies to both of those. That's why we have a to the n times b to the n. And here, when we are raising a power to a power, then we know that we multiply that. So we have a to the m times n. When we are multiplying like terms with different exponents, we would add those exponents. So here if we have x to the third times x to the second, that is going to be x to the third plus x to the second, which equals x to the fifth. And again, if we need to look at that broken out, we have x to the third times x to the second, and that gives us x 1, 2, 3, 4, 5, x to the fifth. And again, looking at the property of parentheses and exponents, we know that this n goes to both the numerator and the denominator, so we make sure to break it out. And that is a quick review of our properties of exponents.